Hello students, so we're going to go through some examples in section 9.2 on linear regression. So before we go through the examples, I want to highlight some important information in the section that will help you understand what linear regression is all about. Okay, so let's start by looking at the first few sentences in this paragraph here. And it says, after verifying that the linear correlation between two variables is significant, the next step is to determine the equation of the line that best models the data. This line is called a regression line, and its equation can be used to predict the value of y for a given value of x. So in these first couple of sentences, it tells you what we did in the previous section, okay, section 9.1, right, where we looked at paired data, okay, and we were interested in determining whether a linear correlation, okay, between the two variables in question exists, and whether that linear correlation is significant. Okay, so that's what we did in section 9.1. Okay, so in this section, once we know that a linear correlation exists between two variables, okay, and that linear correlation is significant, right, then we want to come up with the equation of a line that will best model the data. Okay, and that's what the regression line is all about. Okay, so this talks about how we determine that regression line, so I wouldn't worry about that too much. Okay, so I'm going to skip over that. All right, so let's look at the definition in the middle of the page. So this is page 486. So in the middle of page 486, it tells us that a regression line, also called a line of best fit, okay, is the line for which the sum of the squares of the residuals is a minimum. Okay, so it's not going to make a whole lot of sense, and we don't have a lot of time to cover that. But basically, the idea is that any regression line for paired data, right, is going to minimize the distances between the points in the scatter plot and the actual equation. Okay, so the line of best fit, right, will minimize these residuals. Okay. Unfortunately, we don't have enough time to expand on that and really talk about what that means. So we'll go ahead and move on. Okay, but just realize that a regression line, right, best models the data. Okay, so let's go to the next page. Okay, so what will the equation of a regression line look like? Okay, so it tells you in this box here on page 47. So the equation of a regression line for an independent variable x and then a dependent variable y has this format here. So it looks like y equals mx plus b. So if you've ever studied algebra, you are probably familiar with the equations of lines. Okay, and one way to write the equation of a line in algebra is in the format called y equals mx plus b, which is also called slope-intercept format. Okay, so when we write the equation of a regression line, we're going to write it in the slope-intercept format that you're probably familiar with in algebra. Okay, so because the regression line is used to make predictions based on our data, okay, instead of using y here, we're going to use y hat. Okay, where the symbol y hat is the predicted y value for a given x value. Okay, so y hat is basically the variable y with the caret symbol on top of it, so it's pronounced as y hat. Okay, so y hat is equal to mx plus b. All right, so then what are the other variables? So we know that x is the independent variable. Okay, but what do the other letters stand for in the equation? Okay, so m is the slope of your regression equation. Okay, so the slope tells you how the line is angled, right? Whether it's angled up or angled down, and by how much. Okay, so m is the slope of the line. Okay, and then b is the y-intercept. Okay, so for any line written in slope-intercept format, okay, the b value, right, is always the y-intercept. So it's the place on the y-axis where the graph crosses. I'm sorry, it's the place. Yes, it's the place on the y-axis where your line crosses the y-axis. Okay, so that's why we call it the y-intercept. All right, and then they give you these fancy formulas for calculating the slope and the y-intercept. Okay, so for obvious reasons, we're not going to be using these complicated formulas, but we're going to be using StatCrunch to come up with the equation of the regression line for our data. Okay, so let's go ahead and look at problem 1 in the homework for section 9.2, and it says, find the equation of the regression line for the given data, and then construct a scatter plot of the data, and draw the regression line. And then it says in parentheses here that the pair of variables have a significant correlation. Okay, so you've already done the work to show that there is a significant linear correlation between the height x of a building and the number of stories of that building, which is the variable y. Okay, so we don't need to go through that. All right, and then it says use the regression equation to predict the value of y for each of the given xi's, if meaningful. And we'll talk about what that means, if meaningful. All right, and the table below shows the heights in feet and the number of stories of 6 notable buildings in a city. Okay, so A, B, C, and D are the given xi's for which we were asked to make a prediction. Okay, so let's go and copy the data. Okay, then go to StatCrunch. Okay, so we have the heights and then the number of stories for these 6 randomly selected buildings. All right, and the first part of the question is asking us for the equation of the regression line. Okay, so it's already set up for us, right? So y hat is equal to mx plus b. Okay, so the slope is going to go in the first box, and then the y-intercept in the second box. Okay, so let's go ahead and go to stat. Then we're going to go to regression. So because we're talking about linear regression, right? We're gonna select simple linear from that menu, from the regression menu. Okay, so the x variable is the height x of the buildings, and then the story is y. Okay, so remember that those two are together. Okay, so be sure not to confuse it with other variables that might have similar names in your spreadsheet. So height x, and then the y variable is stories y. All right, and we can do a hypothesis test, but I'm choosing not to. Okay, we want the fitted line plots. So let's go ahead and click compute. Okay, so it's going to give us all this information. Okay, so the dependent variable is y, the number of stories in the building, and the independent variable is x, which is its height. Okay, then below that, it gives you the equation of your regression line. Okay, along with a bunch of other information which we're not going to really worry about. Okay. Okay, so remember, right, we want the slope and y-intercept. Okay, so you can look here, and it might be a little confusing to kind of interpret that. Okay, or you can kind of look in your table, right? And in the table, you see the words intercept and slope. All right, so you can clearly identify which one is which. Okay, so the slope is this number here. All right, so if we go back to the problem, okay, it says to round the slope to 3 decimal places as needed, and then to round the y-intercept to 2 decimal places. Okay, so it wants us to round these to different numbers of decimal places, so you want to be careful of that. Okay, so our slope to 3 decimal places is the number here, so 0.050. Okay, so that means 3 digits after the decimal point, so 0.050 would be the slope there. Okay, and the 2 decimal places, we want the y-intercept. Okay, which is this guy here. All right, so 14.75, Okay, because that number after the 5 there is a 7, right? We're going to round that 5 up to a 6, so it becomes 14.76. Okay, so the equation of our regression line is y hat equal to 0.050x plus 14.76. All right, then it's asking us to choose the graph that contains the scatter plot and the graph of our equation. Okay, and I believe it's on the next slide of the results. Okay, so here it is. So you can see that the line slopes upward, right? So the line has a positive slope, which it does. Okay, and then these are the individual points which represent the data. So again, you put your cursor over an individual point, it tells you that that building, right, has a height of 628 feet and is 48 stories tall. Okay, but in any case, we want to select the best graph that represents the data. Okay, and only one of these graphs is correct. Okay. All right, so answer choice A was the correct graph. Okay, the others were incorrect. So remember, you can also eliminate some of the answer choices, right? So obviously our line slopes upward, right, rather than downward. So in two of these, right, you can eliminate C and D, right? So just be aware of that. All right, so we're going to continue. Okay, so part A says to predict the value of y, or value of y for x equal to 499. Okay, so if a building is 499 feet tall, right, about how many stories would we expect it to be? Okay, so now that we have the equation of our regression line, now we're going to use it to make predictions. Okay, so part A says predict the value of y for x equal to 499. Okay, so for a building that's 499 feet tall, right, about how many stories would we expect it to be? Okay, based on our regression line. Okay, so the x value here is 499, and we're going to plug it directly into the equation of our regression line to find the predicted value of y. Okay, so let's go ahead and use our calculators. Okay, so x is 499, so we're going to hit 0.050. So remember, that's the slope of our line. Okay, that multiplies whatever x value we plug in, so times 499. All right, and then we're going to add to it the y-intercept, which is 14.76. Okay, and that's going to tell us the predicted number of stories that this building should be. All right, so we get this decimal, 39.71. All right, so if you look at our answer choices, right, these are the answer choices. Okay, and neither of them look like what our calculator is giving us. So remember, the number of stories in a building is a whole number. Okay, so we're going to go ahead and round that to the nearest whole number, so 39.71, when rounded to the nearest whole number would be 40. So let's select answer choice B. Okay, same thing, predict the value of y, right, when the building is 646 feet tall. Okay, so same thing. Okay, so 0.050 times 646, okay, plus 14.76. Okay, once again, if we get a decimal, let's go ahead and round it to the nearest whole number. Okay, so that would appear to be close to 47. Okay, so we'd expect a building that's 646 feet tall to be about 47 stories. All right, and then lastly, we're going to make one more prediction. Right, predict the value of y for x equal to 318, and then choose the correct answer. Okay, so we can go ahead and plug that in. Okay, so 0.050 times 318, okay, plus 14.76. Okay, we're going to get that, if it's rounded at the nearest number, that this building that's 318 feet tall, right, it should be approximately 31 stories. Okay, but remember that any predictions that you make with your regression line, right, should be made within the scope of your data set. Okay, so I encourage you to read this paragraph on page 49 because it talks about that. Okay, now if we look at the scope of our data, right, we see that the lowest data value is 478, and the highest is 768. Okay, so 318, right, is outside the scope of our data. So a prediction based on that x value is not going to be meaningful.